Stand.
As always, if music is too loud, just let me know. Oh, you can't see me. Wait a minute. Hold on. Yep, that's me. Let's see. Is light okay? I think it's okay. I hope I don't run out of battery. I forgot to charge my little lamp. So yeah. Cool. Let me just see what I'm going to present. First of all, it's this spot over here. Yeah, should be fine. Cool. Comment here. For some reason, I sent the link to. Hey, Tammy. That's weird. I'm used for you to join in on stream, and now I'm sorry. How was this called? It's YouTube and Twitch? Yeah. So on Twitch, but now I see the L instead of your I think it's like a blue icon. I'm not sure. But hey, nice to see you. Cool. Let me just get rid of the banner real quick. In the comments, I'll send the link for you to register. There we go. In the meantime, let me just prepare the slides. They're here, ready. Do I have them on stage? Ready to be on stage? Yeah, should be fine. Cool. Hello to India. Is it Satvik or Satvik? Not sure. But help. Cool. So you will need. The only thing that you'll need is Python, and if you could create an account in, I don't know how to pronounce this. I guess it's Wokwi, or Vokvi. I'm not sure. But here, okay. Just create an account there. Well, we're just going to use it real quick at the end. We can simulate more stuff if we have time. But yeah. Cool. Awesome. So let's see. Okay, cool. So, hello. Welcome to MQTT. I think music is a little bit loud. I'll just going to maybe 14. Maybe. Is that good? Just let me know if music is too loud. Okay, so who am I? My name is Chavo. People call me Boy. I am 24 years old. I am a robotics engineer. I'm also working in the fellowship part of MLH. So if you're interested in the fellowship, just let me know. I'm a pod leader, and I'm also helping Amanda, which is the one in charge of the fellowship, to basically run the fellowship. Okay, cool. So happy to have you all here. We're going to talk about MQTT and IoT. Okay, simple. Okay, no worries. Let's take a look at that. I don't want to be the spotlight. Wait a minute. That's not good. Is this better? Oh, that's better. Okay, cool. So slideshow over here. Let's see what this is going to be about. So MQTT and IoT presented by myself. What's MQTT? So MQTT is a lightweight publish subscribe network protocol for machine-to-machine communication. Okay, basically, I can send some information through a channel. That channel, or someone can subscribe to that channel and say, hey, I want to listen to this. And you can listen to that. Okay, It stands for Message Queuing Telemetry Transport, okay, MQTT. Okay, and it kind of looks like this. So you see here we have a publisher. It's a moisture sensor. Okay, it could be anything. It could be temperature sensor. It could be any sensor that you like. Okay, that sensor will send data, okay, through a broker, which is the cloud. Okay, that cloud will send it either to the subscribers or to another subscriber that can be the actuator. Okay, actuator might be, I don't know, if it's a moisture sensor here and it says, hey, we have low moisture, and then our actuator is a water pump that activates. Okay, and we just pump water and that's it. Okay, problem solved. Now, we can also subscribe via computer or phone, not with an actuator, but just for the purpose of seeing what the heck's going on, okay? Because maybe you built a big IoT network at home, okay? And I don't know, you went to the beach or something, and you want to see if your house is, I don't know, your plants are being taken care of by your network. So you can just open your phone, check the data, if it's okay, if everything makes sense, okay? All of that via MQTT. Okay, cool. Now, some things that I want you to, this is horrible. Wait a minute. Why did I? Yeah, that's better. Let me just center it. I hate it when it's not centered. Ah, there we go. Cool, my bad. Sorry, cool. That looks way better. Okay, so a broker is the server that receives all messages and distributes them to the right clients. Okay, so here that's the broker, okay, like a cloud. It can be Mosquito, HiveMQ, EMQX. You have lots of options for brokers with MQTT. Okay, a publisher, it's some device or app. Device can be a sensor, even an actuator, that publishes or sends data to the broker on a specific topic. Okay, what's a topic? You can see here a topic at the bottom. It says a string like a channel. Okay, that organizes messages. For example, we can have home/living room/temperature. Okay, so you can have different topics that are like, picture them as channels in a radio. Okay, you can go up to, I don't know, 118 hertz. Okay, and then you go back to, I don't know, 20 hertz. Okay, it's just an example. And then you go up to 90 hertz. Okay, so every one of those are channels, and you can tune into a channel. Same thing here. Okay, a topic, it's a channel where you can tune in and listen to that channel's strings. Okay, makes sense? I hope it makes sense. Okay, and a subscriber is basically someone that wants to listen. Okay, a device or app that receives or subscribes to the data from a topic of interest. Okay, in this case, we have home/living room temperature. Okay, it could be anything. It could be, I don't know, garden/tomatoes/moisture. Okay, it could be whatever you want. Okay, let me just move my computer. There we go. Cool. Okay, so that's MQTT. Okay. For people who don't know what IoT is, it means Internet of Things. Okay, it's a network of technologies that connect and exchange data through the internet. Okay, it can like, we have a lot of use cases for IoT. For example, a smart city, you can see it here, smart home, smart transport. You can see the trend of smart, okay? Smart grid, smart factory, smart farming. Basically, you can connect electronics to whatever you want and control them from whatever you want, okay? Thanks to the internet, okay? As long as you have internet, you're going to control them, okay? It can send you data. It can activate whenever you want, a camera, a sensor, a motor, water, I don't know, whatever. Okay, it's up to you. It's up to your imagination. Okay, cool. And now, next, if you're not like very used to IoT and you want to start, okay, what we usually use for IoT is a microcontroller, an Arduino. Maybe I should have put, wait a minute, I should have put an Arduino Uno here. Okay, Arduino Uno, because the Uno has the Wi-Fi chip embedded to it, okay? And then ESP32 is a good option too. If you want to go and use an Arduino Mega, for example, which I have one, you have to buy like a card, like a chip that connects to the internet. Okay, it doesn't have it embedded like an ESP32 or an Arduino Uno. Okay, cool. You can use sensors, temperature, proximity, whatever you want. Okay, and actuators could be an LED, could be a relay, a motor. Okay, it could be anything that you want. It's just imagination. So if you want to start with IoT, what I do recommend is going to Tinkercad. We can go to Tinkercad. Okay, we're not going to use Tinkercad for the stream. Okay, but you can log in here. What should I do? Personal? Is it personal with me? I think it is. Yep, there we go. Okay, cool. So, for example, we can tinker this one, which is from one of my intro to Arduino streams. Okay, and you can simulate the whole thing. It's completely free, and you have a lot of things to simulate. You have a resistor here, you have an LED, you have your Arduino here. Okay, I think you have an ESP too. We don't. Wait a minute. What? We should. ESP. It doesn't. Wait a minute. That's weird. I thought it did. Okay. You have different boards. I think you have the Arduino Uno and the Arduino Mega. Okay. But let's stay with the basics. Okay. There we have an Arduino. You have transistors. Here's a motor. Okay. So don't feel like you have to buy stuff in order to learn Arduino. You can use simulators like Tinkercad. Okay. I'll send it here. Tinkercad. And it's completely free. Okay. If you are going to start to learn, and then if you're going to bring your projects to life, do buy Arduinos. On Amazon, you can find lots of things, lots of kits with Arduinos and different components that you can use. That's how I started. Okay. I recommend you using simulators first, because if not, you can burn stuff if you're not used to it. Okay. Cool. So let's get started. Okay. So open VS Code. Okay. Oh, this is my cheat sheet. Let's get rid of the cheat sheet now. I have my cheat sheet on my iPad, but you don't know that. Okay, so we can start with, let's start with publisher, shall we? Okay, yeah. Cool, so I'll go to string codes. I'll do, yeah, basically, you don't need any expensive setup. You don't need any prior knowledge. If you burn something in the simulator, it just burns. There's an icon of a fire or something, and voila, it's it. You don't need any, like, knowledge or prior knowledge, and it's great to learn. Okay, and it's free, so you can use it. Cool, nice. So let's start. What? Ah, there we go. Let's do publisher.py. Okay, so by the way, let me open a terminal, because we have to create a virtual environment. Okay, so I'm going to do something that's not very good, which is delete this env. Yeah, okay. Don't do this. Okay, just because I know that I won't be using these files after the stream. But yeah, cool. Okay, so does that look good? Yeah, cool. Okay, so let me go to my desktop, and then should be streams and then stream codes. Okay, you can see that if I do ls here, which lists everything that I have inside, I just have Pythons. Okay, I need to create a virtual environment. Okay, so you can do, for Windows, you do py-m venv env. Okay, venv, like this part over here, is a must. This part over here is the name of your virtual environment. Okay, you could do, I don't know, IOT env. Okay, I just like to keep it as env. Okay, enter, and it should create. It takes a little bit of time. Cool. If you're on a Mac or Unix based, which is Mac or something with Linux, do python 3-m venv env. That should do the trick. Okay, it won't work for me. Yeah, it doesn't work. Okay, because I'm on Windows. Okay, cool. So to activate this environment for Windows, env scripts activate just like that, and you run it. Okay, you can see here it says env. Okay, ignore the base. This is conda. Okay, we won't be using conda. I can do conda deactivate. Ah, come on. Deactivate. There we go. Cool. So you can see there's a green env here. That's the name of my environment. It means it's on. Okay. Now, if you're on any Unix-based machines, it should be source env. It's in bin, and then it's in let's activate. Okay, like this. That's for either Mac or Linux. For Windows, it's like this. Okay, cool. So now that you have your VNVs, we're going to do pip install. Was it Bajo MQTT? Was it like this? I forgot. Oh, there we go. Cool. It probably takes a little bit of time for you because I already have it cached. Okay. But yeah, Bajo.mqtt. Okay, that's the broker that we're going to use. Okay. Cool. Now, there we go. So in here, once you have that env set up, let's do import. Let me get rid of this. Bajo.mqtt.client. Okay, as MQTT. Okay, we're going to import that client as MQTT. Import time. Okay, and import random. Okay, we're going to first simulate stuff. Okay, so no actuators needed. Okay, cool. So we need a broker, topic, and we need data. Okay, let's start with broker. Okay, so we do broker equals broker.hive mq.com. By the way, you don't need to install anything other than the library. Okay, that's really cool. Now you can see that the broker is HiveMQ. Okay, it's free. The bad thing about the free ones are that anyone can tune in to my topic and listen. So if you tune into this topic right here, you can listen what I'm sending. Okay, it's like open source. If you want to see it that way, it's like GitHub. You have to pay for your code to be safe or private. Okay, same thing here. Okay, let's do client. I'm sorry, it's topic equals. Let's try to simulate a room and get the temperature's room. Okay, so we can do, I don't know, house, or let's do home / room / I don't know. Let's do baby room / temperature. Okay, that's the topic that we wanna listen to. Okay, cool. Now we create a client. I'm sorry, MQTT.client. Okay, like this. And my bad, it's with capital C. And then you do client.connect. Okay, we connect to the broker. Okay, port 1883, that works. Okay, 60. Okay, let's get to those three one by one. Okay, first of all, we connect to the broker. Okay, can you connect to it? Next one is the port, or actually we can do 1883. This is the port we want to use. Okay, and we can use the 60. It's like a TTL. TTL is time to live. In this case, it's the seconds that a connection will last before disconnecting. Okay, so the connection won't last forever. It'll last, we can say here, 60 seconds. Okay, 60 is good. Cool. Okay, now, so far so good. Well, true. Oh, by the way, if you wanna follow or if you wanna use the codes later, GitHub, and then where's me? Repositories. Give me a second. Where is my link? Open source 2025. There we go. You'll find here every like the codes from yesterday, from today, and for tomorrow. Okay, cool. So the temperature equals, let's round the numbers. Okay, so round random dot uniform. Okay, we get between 20 and 35. If you live in like very cold places, you can do, I don't know, like Canada would be like -20, I guess. I don't know. I've never seen snow. I do want to see snow someday, but yeah, I don't know what snow looks like. Of course, aside from TV, I don't know how it feels, you know? Okay. And we want to round it to 2 decimals. Cool. So we get the temperature, which is a random number. We can do client that's publish. Yep. And where? Okay, we want to publish. Okay, to what? To the topic. What do we want to publish? Temp. Okay, this is the topic that we're going to talk with the other part. Okay. Cool. Now we can print. I love fprints. So published. Temperature of. We can do temp, and then we can do this thing over here, this thing over here, Celsius. Okay, cool. This is just for show purpose. Okay, you don't need this, but let's see it. Okay, it's always good to have prints, especially when you're talking between 2 things, because you don't know where the connection will or where the code fails. So have a lot of prints. Okay, cool. Time to sleep. Let's do 2 milliseconds. Okay, always have a time to sleep if you have a while true, so your CPU doesn't get overloaded. Okay, cool. Let's run this. Let's see how it looks. So we can go here. We can do Python. I'm sorry, Py publisher.py 3, 2, 1. Okay. You can see we are publishing numbers. Now, where? Like, it's going somewhere. Okay, someone who might have this same topic might be able to listen from this port. Okay, that is connected to HiveMQ. Okay, let's do that. Let's see how this looks. Okay, and for that, let me just open a new window here, do the same thing. Let me just go to desktop, streams, stream codes, and then env scripts activate, because I need to run 2 different codes, and then conda env activate. Okay, I just do this because I have conda activated. Yeah, why not? Cool. Okay, so we have the publisher. Let's create something called subscriber. Okay. Okay, for the subscriber, where is it? There we go. Okay, same thing. Import paho.mqtt.client as MQTT. Okay, get rid of this. By the way, if you don't know how to do this in Visual Studio Code without using the mouse, Control B. Yep. FYI, okay. Cool. Okay, so broker, we need a broker too, equals broker dot HiveMQ.com. I said .com. Okay, cool. Now make it giant so much more fun. I guess something that I want to do is kind of roll snow and making it bigger and bigger. I don't know if that's possible. I've seen it in cartoons. I want to try it. I don't know if that's possible. But yeah, where do you live, Tammy? Just out of curiosity. I live in Mexico, so I'm in Puebla, Mexico, which is the center part of Mexico, so no snow here. I have to go to the mountains, which is like 2 hours from here. But yeah, someday I'll see snow someday. I want to go to Canada, maybe next year. Okay, cool. So the topic is going to be, remember what was the topic? It was home, baby room, temp. Okay, so /home, was it /home or home? I'm used to. There we go. / baby room / temp. Oh, temp. There we go. Cool. Okay, so we have the same broker, we have the same topic. Okay, and we're going to break this. Okay, I'm going to show you that if you subscribe to another topic, this won't work. Okay, cool. Now, let's create a function. Okay, a callback function that activates whenever it gets a message. Okay, you get the client, the user data. That's what it'll receive. Okay, and a message. Okay, maybe these two we're not going to use them for now, but it's still good to know that they are there. Okay, so on message, yeah. Okay, let's do, I don't know, function that activates when it gets a message, okay? Like a callback. Okay, cool. And now we have the temperature equals float, because it doesn't come in numbers, it comes in strings. So float message dot payload dot decode. Okay, cool. Now status equals, let's imagine that we want to simulate a fan. Okay, the fan will be turned on if it's too warm, fan will be off if it's too cold. Okay, so status equals fan on if the temperature, I don't know, is bigger than, at least for me, would be like 28, maybe. Else fan off, and then print I heard temp this C, oh my bad, and status is, there you go. Okay, so we have a status depending on the temperature that we got. Okay, cool. Now, outside of the function, create a client variable, which is MQTT.client. Okay, now client.on message on equals on message. Okay, now why is this important? Because without this, why is this important? This is a callback function. Okay, a callback function means it activates whenever it gets the data. Okay, see, we don't add the parentheses here because when you add it, it automatically runs the function. We want it to run or to store the function in this part over here, and it'll activate whenever something comes in. Okay, Tammy says 2 hours, very far. Mexico is very beautiful to have to visit. In Brazil, you're from London. Oh, that's really cool. I want to go to London. I want to go to the whole UK. They say that it rains all day, and I love it. I do love it. If it rains all day, it's really good. The thing that I wouldn't want, or I'm kind of weirded about London or the whole UK is, and I don't know if other parts of the world, but if you drive, the driver's side is switched. So here in Mexico, we have it on the left side. I think for the UK, it's on the right side. I don't know. It'll be something that I wouldn't drive there, but yeah, I definitely want to go to UK. Cool. Okay, so nice. Client.connect. Okay, we want to connect where? Broker. What port? 1883, same port than before. Careful. If we connect to another port, won't work. And again, 60 seconds for connection time. Okay, cool. Now, see here we said client.publish, client.subscribe, okay, to the topic. Okay, which is the topic? My baby room and the temperature of the baby room. Okay, we can have baby room moisture, baby room something. Okay, it's up to you. Cool. Now, print listening for temperature updates. 3 dots, because when you're waiting, 3 dots is good. And then client.loop forever. Okay. What this does is instead of having it while true, looping forever for us, we can have this. Okay. Cool. 3, 2, 1. Let's run the first one, which is publisher. Okay. Hey, publish temperature of 28, 33, so on. Let's see if the subscriber works. Listening for updates. Oh, see that? Now I got a 32.9. 32.9, here it is. Okay. 33.5, 33.5, 21.87, 21.87. So we're getting, it's a pretty decent speed. Okay. So whenever I send something, I receive it here. Okay. You can see it reacts with the fan off and fan on. Okay. And this is really good. The fact that you get to react to whatever you get means that you have full control from one side to the other. Okay, cool. So before we get full control, okay, I said Control C. There you go. Nice. So if you were wondering how I clear the terminal that fast, Control L does the trick. Okay, cool. So this is the logic behind everything. Okay, now what if I do temperature? Okay, it's the same. It's home, baby room, it's temperature. Okay, let's try that out. I'm sending data. I'm connected to slash what? Does that work? That shouldn't work. Wait a minute. What? Temperature. Huh, that's weird. That shouldn't work. Wait a minute. Is someone sending? I'm not sure if someone is sending this. Let me change. Instead of baby room, I'll do my room. Okay. And here should be my room. Okay, temperature and temp. Okay. Maybe it's someone that was connected. There we go. I publish. And 3, 2, 1. See? I cannot listen to anything, okay? Because even though I'm at my room temp and here my room temperature, I won't be able to listen to something, okay? Now, why this worked? Because I'm pretty sure someone that was following me or following the code along had the same topic and I connected to that person's topic, okay? Now, see what I mean with this is a public broker. It's free to use, but it's not private. So I can connect to, I can even stop this. And if someone is sending baby room, should be temp. Let's see if the code's still running on that person's side. Yes, it is. See, even, oh, my bad. This is the, there we go. Control C. Let's see if that person is still sending messages. No, okay, they stopped it. But I can connect to whatever in the world and listen to updates. Okay, if someone wants to update this, run your code with baby room temp, and I should be able to listen from port 1883. Okay, oh, got it. See? Oh, no. Yep. So, yep, if you want to run it, let's just wait for someone to run it. In the meantime, let's see it. Okay, now, everything's a terminal, not bad. It works. Let's prettify stuff, okay? So, next one is going to be, cool, dashboard.py. So, no one's sending? Okay, no worries. Cool. So, wow, my brain just did something great there. I don't know, I just closed that. CD desktop, stream code, and then conda deactivate, and then env scripts activate. There we go. Sorry. Cool. Okay, so have you ever used Streamlit before? Streamlit is a Python, let's call it library that allows you to create easy, if you want to see them like notebook-like web pages, so that you can add graphs, stuff like that, okay? So let's do one, and let's see this temperature as a graph, okay? So what we can do is let's do dashboard.py, okay? We do need Streamlit, okay? So go into your terminal and do pip install Streamlit, okay? Cool. While it's installing, let me just add a banner, a friendly banner that says, there you go, ask me anything. Cool. Okay, so while it's working in the background, okay, import Streamlit as st, import paho.mqtt.client as MQTT from collections, import DQ. I'll explain what DQ is, okay? It's like the user interface. Yep, that's the one, Tammy. For things like this, it's really easy to use. You found lovable very exciting. Is lovable Python Python it's like Streamlit. Lovable, is it? Ooh, introduction. Ooh, from Python to Go. What? Hey, that's cool. Check this out. Lovable. Oh no way! It's like an it's like an AI. Is it like chat or something? So it's this. I don't know. Can you create some print with Python? Oh, I have to sign it. Okay, later. But cool. Thanks for sharing, Tammy. Lovable here. Let's do it here. Okay, cool. So from collections, import DQ and import time. Okay. Now, same thing. Broker equals broker.hivemq.com. Okay. Now we can do topic equals, it's the baby, so it should be home/baby room/temp. Okay. And then let's start with, we want to store the temperatures. Okay. Ooh, Tammy says it can create a website with prompting really beautiful UIs. That's really good. AI is fantastic. When you want to do stuff really fast, really cool. Thanks for sharing, Tammy. Okay, you say, where does the topic get those temperatures from? See, we have two. Okay, we have the publisher and the subscriber. When you do this topic, let's say it gets spawned. Okay, it gets created and it says, hey, in port 1883, we want to create a new topic that's called home my room temp. Okay, actually it should be baby room. There we go. In this topic, I am creating random numbers from 20 to 35 and sending them. Okay, that's my temperature. Okay, so I'm using the topic as the channel to send these random numbers. Make sense? Is that okay? Cool. Okay, nice. Cool. Okay, so we want to store the temperatures. Okay, and we want it to be fast. DQ means double Q. Okay, so what we can do is collections gives you this double Q that you can use as a list, append and pop work, but it's O of 1 in time. Okay, it's pretty fast. Okay, so let's use that one to pop and append stuff very, very fast. Okay, so we can start by saying temperatures equals DQ, and then is it DQ like this? Yeah, there you go. DQ max line equals 50. Okay, we don't want to get past 50. Okay, cool. So we start adding a title, streamlit the title, and here we can do IoT baby room. Let's do, I don't know, temperature. Okay, cool. Now we have to create a chart. Okay, chart equals st.line chart like this. Okay, so it's a chart, it's an empty chart. Okay, my computer is going weird. Can you, if you listen to my fans, just let me know, right? Because the fans on this computer is just very, very loud. Okay, def on message. Okay, same callback function. We do client user data. Even though we don't use them, you know that those two are there. Okay, and message. Okay, so we can do callback function that activates whenever we get data from sender. Okay, happy face, always be happy. Temperature equals float, the float of the message, that payload, the decode. Okay, this comes in byte form, we have to decode them. Message, payload, decode, payload, yep. And then temps that append. Okay, temp. Okay, so we're getting the temperature, decoding it into a float, and then appending it to these temps over here. Okay, now same thing, client equals MQTT.client. Okay, next thing is client that on message equals on message. Okay, the function here. Okay, hold on a minute. Let me just, can I do this? Wait a minute. So y'all can see this. Yeah, this is just too much. Ventilator. Let's see if I can do something different. Can I do? Yeah, there we go. Yeah, it was at full speed. My bad. I wasn't listening to anything because the fans on this thing is really, really loud. Cool. Great. I can listen to lots of things. Okay. Even the music. Cool. Okay, on message, and then client.connect. I'll connect to the broker. Okay. I'll connect to port 1883, my bad, and 60 seconds. Okay, we know this. Now, client.subscribe, this is not going to send any data. It's going to only consume the data that we get from the sender. Okay, so subscribe to sorry, topic. The topic is baby room temperature. Okay, and then client dot loop start. Okay, then we have to create a placeholder. Okay, placeholder equals st.empty. It has nothing in it. Okay, it's just the title. Okay, now st.empty should be good. And now while true. Now, why we should we use while true here? This is for Streamlit to work. Okay, pure Streamlit only, this part over here. Okay, while true, if we have temperatures, then placeholder dot line chart, the one that we have before, list temps. Okay, and then we can do time.sleep. Let's do 1, so it doesn't take that much time. Okay, cool. Let's review what we've done. Same thing, we have a broker, same topic, baby room temperature topic. We have the temperatures in this DQ, which is the double queue. Okay, it acts like or a double-ended queue that acts like a list. It's just way faster. Okay, of a max line of 50. The title of our Streamlit page will be IoT baby room temperature. Okay, this on message is our callback function. It will activate whenever it gets something received. Okay, connect to 1883, 60 seconds in the broker, subscribe to the topic, we know that, and pure Streamlit. Okay, ready to run it. The only thing that you need is Streamlit run. Okay, it's not Python, it's Streamlit run dashboard.py. Okay, there we go. And you should be able to see it now. Cool. See that? It says IoT baby temperature. Okay, it's like it gives you like or at least it gives me like a Notion vibe. Okay, it's like a Notion. Have you ever used Notion before? I used it when I was at uni. It was really good. Friendly, easy to use. We have nothing. Okay, it's on. It has nothing in it because we are not sending any temperatures. Okay, so what do we need to do? It's send temperatures. So we're sending data now. Yes. Errors. Line chart. Oh, my bad. My bad. Yeah, I said Control Z. There you go. It's line chart. Line underscore chart. Okay. My mistake. I'm sorry. Let's see it again. Cool. It should be already subscribed. Okay, so we should get the numbers. Oh, see that? A chart is being created. See that? The first one is 26. The next one is 30. 33. You can see the temperature here. Okay, so going back to this part over here. Why is my Streamlit like this? There we go. Going back to this part over here, you can see that we can have a publisher. It goes through the broker. It either goes to the actuator, which is your fan in this case for the baby room, and or it can go to another subscriber, which is a cell phone, for example. So let's say that you are, I don't know, your baby sleeping in their room. You are sleeping in your room, and you're like, hey, is baby okay? Let me just check my phone. And because you know MQTT and you watch my stream, you can say, hey, let's do it with Streamlit. And this is what you should be seeing. Okay. Now, ideally, this shouldn't be a temperature thingy. If you have a temperature like this, then you have more issues than just go and see the baby because this is not normal. But yeah, this is what you can use this for. Okay. Why is this important? It's not only IoT is not only about you or a sensor connecting to MQTT and then something automatic, but also for you to see it. Okay. Did you apply filtering? What do you mean by filtering? What are we filtering here? Because okay, like just remember that this is just pure random numbers. Okay, like this shouldn't be like this in real life. But yeah, why not? But what do you mean? Like what should we filter here? Okay, in the meantime, yeah, I could do like smooth the value. Oh yeah, for sure. So you can do filtering. Okay, now that's on the hardware side. Okay, because this is a very noisy signal, but it doesn't make sense because it goes from 21 to 31 degrees. Like it just goes up and down with 10 degrees, and that's not usually what happens. But for example, for your case, like for the filtering, if you have like a what's this called, a proximity sensor, okay, you see that sometimes it's like tickering between 30 and 31 centimeters, for example. You can smooth it out with a filter. You can add a Kalman or something just easier, but yeah, it's for sure. Ooh, okay. Can you please explain the application of the DQ function? Okay, cool. So, let's see. Let's go back to the code. There you go. So DQ is a part of collections. Okay. What it does, it's a double queue. Okay, it's like having a list, and we can append and pop from the same, or like we have. Okay, let me draw it for you. Okay. Let's say that you have, where is the DQ? Okay, here. So let's say that you have a list. Okay, so DQs works as lists. Okay, you have, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, like this. So for example, the DQ, the good thing about it is that it's big O of 1 in time. Okay, so it's really fast because it has you can see it as a pointer here and all the way up to here. Okay, so D stands for double, E for ended, and the Q. Okay, so if you pop, it knows where to pop from. If you append, it knows where to append from. Okay, you can use a regular list. Like lists take big O of n time to reach to the end. Okay, because it's 1, 2, 3, 4, 5, 6, and the DQ has a pointer in the first and in the last number. Okay, so it's way faster because you just point to the number. Make sense? Does that make sense? I hope it does. But yeah, that's how it works. Okay, it's big O of 1. Cool. You can access elements from both sides of a typical DQ. Yeah, exactly. You mentioned filtering would be hardware thing. Would you implement the filtering on the publisher or the subscriber if it's doing it's in the software? Okay. It's just because it's way faster to use it. If you use a regular, it won't change anything in this code. If you use a regular list, we can actually try it. So let's try it before. We can do temps is a list. Okay. Temps that append. There we go. That should do it. It may take a little bit of time after some time. Okay. So you can see it here. See, works the same. It's just whenever you're working with real-time things, the faster you read and you react to your signals, the better. Okay, because if you have like, that was weird. If you have like, what? Okay, that's weird. I'm not sure. What? Is it okay, Mr. Streamlit? Is that okay? I'm not sure. Let me just stop it again. Stop this. Probably oversold it. I think I know why. I think it's because you're connected to the same topics, so it's getting bugged. But yeah, what I was saying was, it's a regular list. It's pretty fast. The faster you have connected to your signals, the better. So it's real time. Okay, makes sense. It's just for show in this case. But yeah, I would use DQ for real life case scenarios. Okay, great question. And here you said, the meme said, you mentioned filtering would be a hardware thing. Okay, would you implement the filtering on the publisher or the subscriber if it's doing it in software? Okay, so your publisher is going to be an Arduino, for example. In this case, for the baby room, it's going to be an Arduino or an ESP32 that gets the signal from your hardware temperature sensor, decodes it, and then sends it. Okay, now that's your publisher. Your subscriber is, I don't know, a Raspberry Pi that works as your server at home. Okay, and that's your subscriber because it's listening to your sensor. I would do it on the publisher because it's way easier to decode and tune your hardware on the hardware side rather than just tune it in on the subscriber side, because if not, you'll have to tune every single one of your hardwares in one piece of code, and that's horrible. Okay, you wouldn't like to do that. So if you have an error, you don't have to go through every single sensor. You just go to the sensor that has the bug. Make sense? I would do it on the hardware, on the publisher side. It's just easier. Okay. But that's a good question. Cool. I have an ESP32 sensor at home, and it filters the subscriber side. That's fine. Like, you can do it. I do recommend it filtering on the publisher side, so it's not, if you have a bug and you have, let's say, 20 sensors connected to one broker, you don't have to go scroll all the way, like all the 20 sensors, and see which one has the error. You can just pin out the one that has the error and go there, because it can be a hardware error, it can be a software error. It's just for easiness. Okay, it's like having different functions instead of one single function for the entire code. But it's like, it should work. It still works. Okay. But yeah, interesting meme, or the meme. What do you have at home? Like, do you have a temperature sensor, and what else? Like, do you have like a network or just a temperature sensor? Cool. Okay, so this is this. Okay, now we have an hour. Okay, it's through assistant, so it's not using MQTT. Oh, it's fine. It's like with Alexa or stuff like that. Oh, cool. That's cool. Nice. Okay, so what else can we do now? Just to show a little bit more of Streamlit. Okay, let's do something a little bit visually beautiful, and then we'll go with a little bit of hardware, and that's it. Okay, a little bit of water. I was going to buy an energy drink. I should have bought that. I don't know. I wouldn't, like, yeah, I wouldn't buy it. I should have. Okay, it's not dashboard. Should be sim.py. Okay, sim. Okay. Meme has a lot of sensors. The one that measures the temperature is also hooked up to an IR LED. Okay, that would turn on the television you were using for your monitor when your computer turned on. Oh, that's really cool. IoT is just beautiful. When you make your home smart, it's just way cooler. For example, I had a project where if I clapped one time, I would turn on my room's light. Twice would be the bathroom, 3 times would be the living room. Okay, and it was done with an ESP and stuff like that. Okay, how to run the Streamlit? Cool. You do Streamlit run, and then the name of your Python. In my case, it's dashboard, and it runs. There you go. See, it's not with Py as a normal Python. It has to be Streamlit run. Okay. Cool. I have it integrated into Google Assistant as well, so I can talk and ask what the temperature of humidity is in your room. Yeah, those are really powerful. I think you can connect ChatGPT too, and it becomes a little bit smarter. But yeah, it's fine. Meme, you're doing it really good. It doesn't stop. What? Control X, Control C. Oh, my bad. Yeah, you can. Yeah, I know. It's. I've seen videos. It's cool. Okay, this got bugged. Let me just rerun the thing. CD desktop, streams. Conda deactivate, and then what was it? env script activate. There we go. Hey, did I miss something? Well, it depends on what missing you mean. In case, or just in case, check my GitHub. I have the codes there, so no worries. We just created a publisher, a subscriber, a dashboard, and now we're going to simulate with another dashboard, okay? You can follow along. Cool, so let's simulate this, okay? So we could do import Streamlit as st, import pahope.mqtt.client as MQTT, import time. There we go. Cool. So broker is the same one. Should be broker dot hype mq dot com. Okay. Meme says I missed the earlier part of this, so this will be answer. But does MQTT function independent of Wi-Fi? I'm feeling that the answer is no. No. So it everything's on Wi-Fi. Okay. It's like imagine it as like a cloud that you connect to that cloud, and everyone can connect to that cloud. But that's why you connect to a certain or a specific port and a specific topic. Okay, so lots of people can be connected to this one over here, but with different topics. Okay, makes sense. You can, instead of using a public broker, you can use a Raspberry Pi to do your own broker. That way, it just filters the communication and sends it to as a broker, and it's yours, and it's on your network. Okay, so it's private, but in this case, we're using a public one, so it's on the Wi-Fi. Okay, cool. Good question. Good question. Nice. Okay. Simulation. Okay. Broker. We know which broker it is. Topic, temperature. So can we do 2 different topics? Hey, Mrs. Married to the Game. Yeah. Let's do, I don't know, home slash baby room slash temp. Okay. We can do topic light equals, let's do home slash bathroom slash light. It doesn't have to be baby room all the time. Hey, I don't know how to pronounce your name, but it should be Mija or Meja. I'm not sure. I'll just stay with Mija. Hi. Cool. So let's see. Now that we have 2 topics, you can see that we can connect to more than one topic. Okay, that means we can have 5 sensors talking to one single broker. Okay, so let's see. Client equals MQTT dot client. We can put it like this. And then client.connect, where broker, where specifically 1883.60. Remember, this is your port. Okay, cool. Now, st the title. Okay, we get a title for our Streamlit. We can do MQTT IOT device simulator. Okay, from there, temperature equals st, that slider. Okay, it will be like a sliding button. The name of it, it's temperature sensor with a min value of 10 and max value 40, and we start the value with 25. Okay, cool. Now, same thing for the light, but in light's case, it's going to be a button. Okay, so light equals to st.toggle. Okay, as easy as it is, as it sounds. Okay, this is creating a slider and a button. Toggle light switch to go to the bathroom. Okay, default value equals false. Okay, cool. Now, if st.button send data, so we create another button that says send data. Okay, so we have a slider, we have a toggle button, and we're creating another button that says send data. Whenever that one is clicked, client.publish, okay, should be topic temperature. What do we send? The temperature. Okay. No worries. Yes, I did. Just in case. Here it is. Okay. The bad thing is it has the codes from yesterday, today, and tomorrow. Okay. Just refer to everything that has the MQTT imported in it, in Python, and you should be good to go. Okay. But yeah, no worries. Thanks for tuning in. Temperature. Now, client.publish. We should be topic light. Okay. We send on. Okay, we're going to send an on string if light is toggled. Okay, so if it's toggled, it's going to be true. If not, it's going to be false. Okay, so we can do if light, else off. Okay. Cool. Now, st.success. Let's send a success string that says data sent. The temperature equals temp in Celsius, and light is on. Oh my bad. On if light, else off. Okay, that's just for us to see. Okay, again, you should always have lots of print statements, specifically when you're talking to different device, so you don't have to, so you know where it breaks. Okay, because it's going to break someday. Time that sleep 1. Okay, sound good? Let's try this and see how it looks. Okay, so we have to have the Streamlit run dashboard.py. Streamlit. There we go. So we have this one running. Okay. So we're going to use this one, put it here. Okay. The other one's going to be this for now. And now, Streamlit run simulator. Okay, let's see how this looks like. Okay, you go here. I said you go. How can I do this? Like this. Here, yeah, there we go. Can you see this? Yes. Okay. So IoT baby room temperature is not reading anything because we haven't sent anything. Okay. Actually, we have to toggle the lights. Let's do that in a second, okay? So first is the default value is 25. We can move this around. Let's send a 10, okay? Send data. See this? It already reacted. Okay, index 0, value 10, okay? Now let's go to 40 and send the data. Okay, there we go. See? So I guess this is happening because everyone is sending everything at the same time on the topic. So I'm going to change it back to, wait a minute, it's a dashboard, right? Let's do the queue here. Was it max? Was it length? I don't remember. 50? Like this? Is anyone following that part of the code? Dashboard, it's max len without this and without this part over here. Oh, there you go. Let's make it faster so it reacts better. I know, my bad. There you go. Oh, I broke the simulator. Wait a minute. Should have been the other one. Let's see. You get out. See, now it doesn't react that way. Okay, now you go here, you go out. There we go. We send the data. We get the data here. Okay, index 0, 25. We can go all the way up to 40. We can send some data here. Let's do it in 13. Send the data. It gets bugged because everyone is sending on the same topic, a lot of data. It's fine. Okay. What does this mean? It means with a simple button, you can make the other side react. And this is really powerful because it means I can turn a light on with some code like this on an ESP32. Let's go and do it. Like, why not? Like, this looks good. Let's see how this looks in an ESP32. Okay. Let me just add something to the dashboard. Should I add it now? I'll add it later. Something with the light. Okay, so it looks like a light here. Okay. Cool. So let's do Control C this, Control C this. Okay. Cool. Now let's go to get rid of this Streamlit here, so I don't run out of RAM. I shouldn't. I have 16 GB, but it should be fine. Get rid of this. Streamlit out, and this one should be good. Okay, this one goes out. Okay, cool. So openwokwi.com, okay, should look like this. Okay, so I'm already logged in. As you can see there, my icon. Click on ESP32. Okay, and go all the way down. Oh, no. I'm sorry. Here you can see some templates. Okay, lots of templates here. Interesting templates. If you want to learn more about the simulator, click on one of these, and you can see how it was made. Okay, I won't dive into like very, very deep into the simulator. I just want to create the broker and see how it works. Okay. You can ask me questions about the electronics if you have any. But I'm not going to dive that much into an intro to the simulator. Okay. You can go to click on your icon and click on your projects. I have this template over here, but I'm going to create a new one. In this part over here, you have lots of options of lots of different boards. Use a regular ESP32. Okay, that should be good. Click Arduino, and that's fine. Okay. Interesting question. It says, in the case of temporary loss of communication, can MQTT provide historical data to the subscriber once the connection is reestablished? No, I don't think so. So I'm not sure. Let's actually see MQTT TTL. I'm not sure. I don't have a real answer here. Let's see if we can read it real quick. Okay, you can see here it says I just lost it. No, where is it? Spy interval. Should be here. Okay. Here it is. Message expiry. Then must delete the copy. Okay. If the message expiry interval was passed and the server is not managed to start owner delivery matching subscriber, then you must delete the copy of the message for that subscriber. Okay. So you can see here, this is like the protocol of MQTT. Okay. I guess the real answer is for the public MQTT that we're using, the broker, I'm guessing it will be deleted because of the traffic and because it's free. Okay. If you were to create a broker in your Arduino, then you could have like you could save the data, and in case you see that it didn't reach the destination, you can resend it. I guess that's the answer that I have. I don't think it actually, like, MQTT by itself stores the data. Okay, I don't think it's in protocol. Okay, because if not, it'll be horrible. It's free. Okay, so I don't think they do it. Okay, if you do your own personalized broker, you can do it, but manually. Okay, that's my take. Okay, cool. So now that we have an ESP, click on the three dots. Okay, let's zoom in a little bit more and toggle the grid. Okay, now this is an ESP32. Okay, it's a board that can connect to Wi-Fi. It has things called pins. Okay, so I actually have it here. This is called the pinout. Okay, you can see that the pinout looks like this. Okay, so you can see this one over here is EN. This one over here is ground, 3.3 volts. This is voltage input, so you can make so the board doesn't eat voltage from here, but from here. This is ground. Okay. These are for input outputs. Okay. And these are, for example, this talks or listens to MOSI, some protocols. Okay. We can use all of them. You just have to know which ones in very specific cases you have to know the pinout. Okay. You can see all of them are GPIO, which is input output, and that's what we want. Okay, so in this case, we're going to use the ESP32. For the ESP32, you can see here there's a piece of code. Okay, you can code this. It uses C. It's like a C++ embedded into this ESP. So it's like its own version of C++, okay? Cool. Now, let me just quickly explain what this means. Serial begin is in 115,200. That number is the bots, okay? It's the communication speed, okay? For the ESP32, 115200 is good. For the Arduino, 9600 is good, okay? If not, then you'll have a discrepancy between reading and writing. Okay, it's as simple as that. Okay, let's just leave it there. Let's just get rid of this one. Okay, that's the template part of it. Cool. Okay, so let's add something. Okay, if you click on this plus sign, you can see there's an LED. Okay, add the LED here. We can change the color. Let's do, I don't know, cyan, because why not? I love this color. Okay, so anode and cathode. Okay, cathode is for the negative, and anode is for the positive. Okay, so let's connect this with clicks to GND. Okay, and let's connect this. You can see here number 2, and so connect it that way. Okay, again. The C means cathode. It goes to ground. Ground is basically negative. Okay, if you want to see it that way. Positive is your number 2. Okay, and it goes to the anode. Okay, cool. Now, if you ask like, hey, what happens if I connect it like inverse? Nothing happens. Okay, the LED doesn't turn on, the LED doesn't suffer. Don't worry, it's a diode. Okay, so it'll be okay. Cool. Now let's start with this part first. Okay, so let me just open my cheat sheet because I don't remember what I should be writing. There we go. Okay, cool. So before everything, you have to go to Library Manager, click on plus, and then add pub sub client. Okay, this is for this ESP to include this library. Okay, if not, you'll get an error and it won't work. Okay, cool. Now, at the first part, let me just try to zoom in here. Okay. Oh, no. I said no. Can I cancel this? Yes. Okay. Yeah, just for you to see the code. Okay. Cool. So we do hashtag include, open the carets, and then Wi-Fi.h. Okay. This is the oh, my bad. This is the library for the ESP to understand the connection of Wi-Fi. And then hashtag include. Everything's on the GitHub, okay? No worries. Pub sub client.h. Okay. There we go. Cool. Pub sub client. Yep, there we go. Cool. So let's add a string. Okay, const character string SSID equals walk we dash guest. Okay, we have to have this SSID or the name of the network as it is like this. Okay, so walk we, the simulator understands that we're trying to connect to the network. Okay, this is a really good simulator. Now, const character star, which is a string for whoever hasn't written C++. Password equals nothing. Okay. Cool. Okay. Now const character star MQTT server equals broker. We know this one. Broker dot hive mq.com. Okay, all good. Cool. Now we have to activate the client. So Wi-Fi client ESP client. Okay, do this, and then oh, my bad. Don't forget the semicolons used to Python, and then pub sub client. It's a client of type ESP client. Okay, that's just for connection purposes. Okay, cool. Now, we need to tell the ESP which pin are we going to talk to. Okay, because we have lots of pins here, but the one that we're connected is 2. GND is just to close the circuit, so you don't have to take care of that. But number 2 is our pin. Okay, so we do const int let pin equals 2. Okay, we just keep it there so it's easier to track. Okay, cool. Now you see we have a void setup and void loop. By default, these two have to exist. If you get rid of either of these, ESP won't run. Okay, that's for the whole Arduino family. Okay, now this number, don't change it. That's the baud. The bauds are the speed of communication for ESP32. This number is good. Okay, don't change it. Now, in the setup part, as the name says, we set up stuff. Okay, so in this setup part, we're going to do pin mode. Pin mode is to say, hey, your pin, which is the let pin, let pin is a type output. Okay, you're not going to receive any voltage from that. You're going to output voltage. Okay, cool. Now, oh, by the way, ideally you should have here a resistor, but don't worry, it's a simulation. Okay, but you have to have a resistor here just to for the pin, for the LED not to get burned. Okay, because if it's a lot of voltage, you'll burn the LED. So ideally you should add a resistor, which is here. You can do it. Okay, it's fine. I didn't miss it. I don't think it's important. Okay, at least not for now. Cool. Okay. We do Wi-Fi dot begin. Okay, so basically connect to the SSID that we said and the password. Okay, password. This will connect to the simulator's internet. Okay, cool. Now, next one is while Wi-Fi dot status, yep, is not Wi-Fi connected, then reconnect basically. Okay, delay 250. This is like a time dot slip. Okay, serial dot print. I'll explain it in a second. A dot. There you go. Okay, serial dot print means I want to print into the monitor, which you'll see when I activate it. Every Arduino board has a serial plotter. Okay, so you can see everything there. It's like your terminal. Okay. Tammy says really cool. I will use this monitor to monitor the decomposition process in a compost bin. You can do it. I don't know if there's like a ammonia sensor or like pH sensor that you can use and use that to like kind of track how the decomposition is. Yep, that's really good. And the moisture too. Nice. Okay, so if we're out of this, it means we are connected. So let's use serial dot print line. Okay, let's print a whole line. How can I do the backslash? I always forget. I always do this. Backslash. There we go. My keyboard is weird. There we go. Control C this. Control V. Backslash N means enter. Okay. Wi-Fi connected. Okay. Cool. Now, client that set server. We set the server of the MQTT server port 1883. Okay. Remember, same port as before. Now, client that set callback. Remember, we need a callback function. Okay. So let's create that. Callback. Okay. Cool. Now, just before we go into the callback part, in the void loop, this is going to run forever. Okay, this is your main loop. This runs first and then the loop. Okay, everything gets activated in loop. It's like a void main. Okay, it's the same thing. Okay, but in this case, it's always looping. Okay, so if you ask, can I get past this? No, you cannot. You have to work with void loop. Okay. If we're not connected, then let's reconnect and let's create that function. Okay. This is for the MQTT part. Okay. Just for that, just loop, just keep it there. Okay. That's fine. And we'll start to connect stuff with reconnect. Okay. Let's first start with all of the functions have to go up. Okay, because everything compiles from top to bottom, In C++, is a little bit that's how it works. Okay. Cool. So let's first start with void. Void means I'm not expecting to return anything. So void callback. Okay. It's the same thing. Remember here we had client, user data, and message. Same thing here, but in this case, it's a char star called topic. Char star, remember it means string. Okay. Byte means like a string of bytes called payload. And unsigned int length. Okay. Shoot, there's a mosquito in front of me. Should I? Oh. Just because I'm in a stream, I won't throw anything at it. I usually do. Okay, length. Okay, cool. Now, inside of this string message, okay, let's have it as a string form, not as a char star. Okay. Now, for int I equals 0, I is less than length, I plus plus. My bad, I plus plus. Okay, what does this mean? If you're not used to C or C++, then it means I want to do a for loop starting from 0 all the way up to the number that is less than length, and I want to go step by step. Okay, you can do I plus 2, for example. Okay, but in this case, I plus plus is I plus 1. Okay, inside of this for loop, let's just append to the message the character of payload in I. It means break down payload, make it a character, and add every single character to this string called message. Okay, now, oh, careful, semicolon, there we go. And now, if message double equals on, then let's turn the LED on. Okay, so we can do digital write. It means, hey, Mr. ESP32, I want you to send to LED pin a high. High is, was it 3? I think it's 5 volts. So it sends 5 volts through that pin. Okay, that's what high means. Okay, and let's do serial dot print line. LED is on. Happy face, always be happy. Okay, semicolon. Is C++ easier to write than Python? Nah. No. Like, I have to write semicolons. I have to basically how to say this? I have to declare every single variable as a char, for example, as a byte. As in Python, you just do this. The good thing about C++ is that it's like probably 10-15 times faster than Python. So it's like, you know, give and take. Like, what do you want your code to be? Fast, but not as readable as Python, or you want it to be in Python, but not fast. Okay. If you use AI, Python is perfect for for a GPT-5 things in Python. Usually for AI, everything in AI is Python. But I don't know if GPT-5 thinks in Python because it's really slow. It would think in C++. So Python is built over C++. So lots of Python libraries are C++ built. But yeah, I'm not sure about that. But if you say so. But yeah, that's the drawback of Python. That's really slow. But for AI, it's just great. Cool. Okay. Else if message double equals off, then we want digital write basically, hey, Mr. ESP, I wanted to send let's pin hello. Low means 0, no voltage, off. Okay, cool. And serial dot print line LED is off. Sad face because it's off. Okay. Cool. Let's do LED. I like it like this. There we go. And semicolon because I always forget. There we go. Nice. So far, so good. Okay. We have our callback. Whenever we get a message, this will be activated. Okay. Nice. Now, the only thing that we're missing is our reconnect function. Okay. If we are not connected, it should be able to reconnect by its own. Okay. So I was going to do def, but it's not def. It's void reconnect. Okay. Nothing from in while we are not connected. Well, we're not connected. I want you to say, hey, serial that print connecting to MQTT. 3 dots, because, you know, it's always good to have 3 dots. I saw your message. Just give me a second. I'm not running out of time. It's not important. When you click show thinking, it shows Python. The backend could be very well be C++. Okay. I didn't know. I didn't know about that. That's really good. That's really cool. Is it showing you the thinking in Python for you to recreate it if you want to use an MCP server? And it's just showing it to you just because? That's interesting. That's an interesting thing. I've never clicked on show thinking. I feel like I'm invading ChatGPT's brain, so I don't dive into that. But that's interesting. I've never thought of that. I'll do that. Thank you. Wait a minute. What? Okay. Hey, hello, Karime. Cool. Okay. So if client dot connect and it connects to we client, it means we're connected. So serial, it'll often run code to solve problems. Yeah. It's maybe you uploaded some Python code and need to run the code in the backend. Maybe. Serial dot print line. We'll do connected. Now, semicolon here. We have to subscribe. Okay, everything, but we have to subscribe. Client.subscribe. And from there, we'll do home slash let's do bathroom slash light. Okay. Who, me? Are you talking about me? I don't think you're talking about me. My Python is not that good. But yeah, thank you. If you're talking about me, thank you. If you're not, then yeah, I'm not that good. There's always room for improvement, but thank you. But yeah, thank you so much. Cool. Okay, so if serial this, else, okay, serial dot print, let's do failed, RC equals, and let's do the state. Okay, so serial dot print. Now, what's the difference between print line and print. If you have print, for example, these two prints are followed like one after the other. If you have print line, then it goes under. Okay, so you can kind of in this case we're going to print after it this part. Okay, cool. So in this case we can do client that date, getting there on promise, and then delay 2 seconds. Okay, always give some time. That should be it. Okay, now let's just see if this works. Okay, I hope this is not bad. I'll just see if, let me just check if I have an error there. Unless you're using projects in ChatGPT, as far as I'm aware, no LLM does anything in the background. No, it just decodes and tokenizes your input, and it should give you an output. I don't know how it works with both images and code. So if you upload a code to it, I don't know if it tokenizes the code, or actually, I don't know how it tokenizes the code. So I'm not sure. I'm not sure how it works. It's like magic, ChatGPT. Cool. Yeah, it tokenizes it. Yeah, LLMs, everything. Yeah, yep. Same with images. Is it? And what about PDFs? What about the Word documents? How that's like magic. I don't know how it tokenizes it, those things. I know how to tokenize words, but not files. That's great. Okay, it's taking a while to compile. That's likely just a decoding. Maybe I would like to know how it works in the backend. Cool. Okay, this should be good. Okay, this should be good. Let's just go into our Python. Okay, because I'm running out of time. Okay, so while that compiles, and maybe I'll get an error. Walk.py. Okay, now in here, I'll do it a little bit faster. Okay, import paho.mqtt that client as MQTT. Okay, broker equals broker dot hive mq. Okay, .com, and then what was the topic again? Remember? I don't. No! Don't do this to me, please. We won't be able to see it. Oh, that's a bummer. Oh, I hope we can see it. Oh, that's going to be a bummer if we don't see it. Okay, let's do. Okay, home bathroom light. Okay, that's our topic. Okay, home / bathroom / light. Okay, if you go to the bathroom at night, it's better if you use your phone. Okay, client equals MQTT that client. There we go. And now we have client that connects. Okay, we connect to the broker. We connect to port 1883 with a 60-second delay. Okay, and now print broker. Okay, I'm sorry, I'm doing it a little bit faster because I'm running out of time. And then, okay, print. Now let's do a beautiful print. Type on or off to control the light. Did it compile, please? Ooh. I hope it compiles. Type exit to quit. Okay, let's do a \n here. Okay, so it goes down. Cool. Now, easy while true here. The command is going to be input command. Okay, we're waiting for the command. We strip it. It means separate it. Okay, and then we lowercase everything. Okay, just in case. There we go. And if the command double equals exit without uppercase, because we already lowered everything, then break. If command in either on or off, it means for us not to do two if statements. You can check, hey, if my command is inside of this, then client that publish. Did it compile? Oh, come on. Please compile. What if... Okay, let me do something. Save project 2. Okay, let me do something real quick. What happens if I go here, I open my projects, open the template? It should be the same one. Oh, cool, it compiled. Okay, I have this one compiled. Oh, that's great, that's great. Okay, nice. Publish topic cmd dot upper. Okay, why dot upper? Because we're expecting in this part off, okay, or on. Okay, cool. Now print f stamped the command, add a little bit of space, and then command that upper. Okay, we send this command. Cool. I saw your message. Just give me a moment. F send command that upper. Oh, my bad. Is it here? Yeah. Cool. And now else print not a valid command. Sad face. Okay. Cool. Awesome. Now this should work. Okay. This should work. Let's take a look at let me stop this. Let me just zoom in a little bit more. Move this around. Now I wanna toggle the grid. There we go. This is the terminal. Okay, this is what serial.print prints. Okay, if I do run, because this one was compiled, I compiled it I think yesterday to see if everything works. So it's listening. Okay, see this Wi-Fi connected, connecting to MQTT, connected. Okay. Oh no, it's fine. Because this one has home living room light. Okay, let's just not forget that. Home living room light. Okay, same port. Okay, 321 pi wcookies.py. Okay, let's send. Let's see it here. See the LED? Okay, it's turned off. Okay, the command is on. Okay, didn't listen. Oh, wait a minute. Connecting to MQTT. Still not connected. Yes. No. Is it good? Should I send it again? On. Ooh. Okay. It's having a little bit of trouble connecting. Let's see if it works. Oh, see that? LED turned on. On. Let's try off. Ooh. Let's try on. Cool. Let's try off. Nice. So I'm sending from my computer to MQTT to this ESP commands. Off. Oh, my bad. On. There we go. And as simple as exit, it's exited. Awesome. Okay. Now I hope it compiles for you because I see there's a lot of traffic. Let me stop this so I don't add more traffic, but that's how it works. Okay. Reviewing everything that we saw. If you have a port and you have a topic with a broker, this is a public broker, you can do a personal broker in your Raspberry Pi or any other computer that you're not using, or if you're using it, it should be on, okay? You can connect stuff. And this is how IoT works, okay? Me from home, I could connect to something that's the server, I'm not sure where Walkwe server is, but I was able to connect via that part, okay? Actually, I dare, okay? This is a dare, or not a dare, this is a challenge for someone who was following me. If you have this code over here, wherever you are, connect to home, living room, right, with this code over here. I'll send it, okay? Yep. If you use that code, okay, from wherever you are, just make sure, yeah, should be fine. Run it, and when this is connected, you should be able to turn on and off the light. Okay, you can try it while I just explain the last things. The broker is public. Okay, it means anyone can turn this light on any second. Connected, should be connected now. If anyone wants to run that code in Python, you can do it. You can turn this light on. Being a public broker, it means anyone can access to your network or your IoT network. Careful, okay? If you're going to use this broker for your personal projects, it's fine as long as you don't expose your IP addresses and your personal data, okay? Careful, okay? Really nice, really nice. I see no one's running the code, it's fine. Yep, Christmas light special coming up. Yes, it's going to be cool. You can, instead of turning it on manually, you can do it via your phone. You know how to do it. Just careful with 120 volts or 240 volts. I don't know where you were at. But yeah, at least here in Mexico it's 120 volts. So just add a relay there, and relay should take care of your voltage difference, okay? Because you don't want to light something with 120 volts. It's just going to do kaboom, okay? Cool. Thank you so much. Last thing is, yeah, okay. So two things. First thing is, please, if you haven't, register here, okay? And second thing is, please give me feedback, okay? Copy link address, paste it here, okay? If you go to this part over here, to the feedback part, okay? You'll get to the survey, okay? If you could spend 3 to 5 minutes to give me feedback so I can do a better job next time. If you want to see something different or something you didn't like, please just let me know. You can just do MQTT. There is it. MQTT plus IoT in Python. Click on next, and how you rate the contents of MQTT. If your score is a 1, I won't take it personal, okay? I just want to see what you like, okay? Cool. Nice. Definitely try it. Just have this created, okay? Good luck trying to compile this, okay? It takes a while because everyone, like, there's a lot of people connected to the server, okay? So good luck. Thank you, Tammy. Anyone, please give me feedback. And yeah, I hope I can see you tomorrow for my YOLO and Deep Sort stream. It's going to be cool, fun. Yep. Thank you so much for joining. I want to ask, like, leave the last 5 minutes for questions. Anyone has any questions? Hey, thank you. Thanks for sticking by, and I'm glad that you enjoyed it. Yeah. This is still running, right? Yeah. Whoever wants to turn this on, just run the code and you can turn it on. Okay. If you're using my GitHub's code, just change instead of. Oh no, should be fine. Should be fine. Yeah, you can do it. For sure. My Discord is bully 1. Yep. I'm on the Major League Hacking Discord, so that's my Discord username. Okay. But yeah, for sure. Learned a fair bit. Thank you. Oh, thank you, Meme. I hope that you can add more sensors to your rooms and make your Alexa or Google assistants smarter. Yep, and I don't know, connect your whole house. But yeah, I'm going to stop this. Thank you so much for joining. Have a great night. At least for me, it's night. So have a great night, and I'll be seeing you tomorrow, hopefully, for YOLO plus Deep Sword, a little bit of computer vision. Okay. Thank you so much. And if you have any more questions, just send it on the Discord, tag me, and I'll be happy to answer. Okay. Cool. Awesome. Thank you all. And Meme says pretty much already. Okay, you have a lot of sensors, but thank you for the well wishes. Awesome. Just be careful with voltage. Okay. I've blown quite a lot of things. Arduinos are some of the things that I've blown. Yeah, just be careful. Okay. Cool. Everyone, please take care. Have a nice one. And oh, you'd be doing the vision code thing tomorrow? Yes, I'll be doing it. The one that's YOLO plus Deep Sword, I'll be doing it. Okay. So I hope to see you tomorrow. But yeah, thank you so much. Take care. Bye bye.